start with a huge thanks. Everyone in this room obviously has business skills, quantitative skills. You've worked hard to get where you are today, and you've decided to work in energy, and particularly the technologies and innovations to do with energy. Call me biased, but I think there's no more impactful place to work in than energy. Literally, you're going to improve lives. The more you drive forward the technology you're working on, the better people are going to be. So I get the honor today to say a few words about energy innovation. I'll start with energy. For almost all of human history, life expectancy at birth was about 30 years. When I look at myself, I think, boy, that would have been a bummer. I wouldn't be here. Today, global life expectancy at birth is 73 years. I mean, just a dramatic transformation. And the story of that transformation is intimately tied, and I think predominantly driven by advances in energy. Improvements in the energy available per person, improvement in the forms of energy that provided not just heat and cooking, but also to turn energy into mechanical power and do all of those things that make it so today, less than 2% of Americans are directly in food production, and we eat 50% more calories than 200 years ago when 80% of Americans worked in food production. Not everyone's a farmer anymore. We get to do all sorts of neat things like what you're doing. Where are we today, though? Massively better than we were a few generations ago, but there's still huge room for improvement, which is why I'm so heartened by the tremendous people in this room. More important today, by far more important today, than my words are going to be my walk around and my travel to learn about the projects, not all of them, unfortunately, but to learn about a bunch of the projects that the people and teams in this room are working on. But today we have about 1 billion people that live a lifestyle recognizable to us. You know, we got lights, heating and cooling. We traveled from wherever you all came from to go to conferences. We travel to see our families. We go watch movies. We play sports that are only possible with a great energy system. And then we have 7 billion other people on the earth that logically, they want what we have. And for them to get what we have, we need massively more energy in the planet today. That's why it's critical that you're working in energy. Half of the people on the world today are walking around in hand-washed clothes. Think about that. I think there's probably no one in this room in which that is the norm. It's just a massive time-saving technology, women and children liberating technology that less than half the world has. Let's get it to the other half. Let's get it to the other half. We've got 2 billion people today, a little over a quarter of humanity, cooking their daily meals, mostly burning wood or charcoal or agricultural waste. This has a few big downsides. One is over 2 million easily preventable deaths per year. The other is the time. When we try to promote these technologies and deliver clean cooking fuels in Africa, to the people from the Western world, this is about saving lives. To the people in Africa and South Asia, this is about liberating them from hours a day of drudgery and improving the daily quality of life of the women and children who do this work. I think there's some ARPA-E ideas in there. How do we get better metering, cheap metering technologies that makes it easier for people to switch to clean cooking fuels? There's huge opportunity, life-changing opportunity for innovation there, and I can't think of anyone that can do more about that than the people in this room. Let me switch from energy to innovation. Look, innovation is what drives progress. It's why we live differently than the generation before us or 5 generations before us, and why our kids and grandchildren are likely to live wildly different lives than us. I got tired maybe about 10 years ago about long formal bios, even short formal bios. Bio just never says anything to me. So I was asked to write a short bio for myself, and it was easy. I wrote the first thing that came to my mind, and I said, science geek turned tech nerd turned energy entrepreneur. And that's really my story. I did get a new job a few months ago, but that was not planned and was not part of the bio. But that's what motivated me. As a kid, I looked up in the sky, and I was first fascinated by stars and astronomy, and I wanted to know how these objects that were so far away I could see with my naked eye. How could I see them? What produces so much energy that from quadrillions of miles away, I can just look up and see them? Like, that started my wonder of science, my wonder of energy. I didn't know it was called energy at the time, but that started that pathway for me. When I was in high school, there was sort of a fear then that the world was running out of energy and materials, and the world industrial civilization was going to collapse, and things were going to get a lot worse for the world. Sometime around the year 2000 was the story as I heard it as a high school kid in the 80s. It motivated me. This sounds awful. I want to be part of the solution to that. And it's why a Westerner, I lived in Colorado, I loved the mountains, I loved to ski, I wanted to climb mountains all around the world. I didn't think I'd ever go back to the East Coast, where I was originally from, but when I left when I was 6 years old. But then I thought, I've got to work in energy. And as a simple mathematician, I thought energy density and quantity of available energy must be the most important things. So I went to work on nuclear energy. It made me go to the East Coast, Cambridge, Massachusetts, no less. That sounded like a terrible idea. But when I got there, I actually loved it, and I realized there's not just, this one energy technology or this one area. There's just so many game-changing things that come from people tinkering away in laboratories, trying to understand mechanical systems or electrical systems or chemistry or biology. I remember as a kid, I didn't want to work in biology because I thought it was a soft science. There's too much memorization, too much. We don't quite know why, but when these two things put together, that thing comes out. But I look at it today, and it's just incredibly exciting, right? We're modeling how proteins fold on an atomic scale, how chemical interactions happen, what drives them, and how they can be driven a different direction. It's become an incredibly hard quantitative science. That's crazy exciting to me. Call me a nerd. It would be true. And so in my work, first in nuclear, then I worked in solar early on, trying to figure out how you take a solar panel to power a remote instrument for a long time. Amazingly, then there were just panels, and then you could buy batteries, but there weren't charging circuits to connect the two. So if you put a panel on and the voltage was high and you bought the wrong battery, that eventually would destroy these batteries pretty quickly. So the first simplest thing I did was just a charging circuit that would make it so when the panel had a very high voltage, the battery wouldn't see that, and it would only charge one way. It wouldn't discharge the battery when you didn't have sun. But in any case, I worked in nuclear, then in solar. By crazy luck, I worked in this super cool geothermal idea of injecting water underground, flowing it through the rocks, and then producing very hot water or steam at an offset well and using that to produce electricity. I thought this was the coolest idea under the sun. This was over 30 years ago. I developed a little spreadsheet model of the phase change in density as that fluid came up the other well, depending on the rate you injected and what % of the water returned. Now we've got fabulous entrepreneurs, maybe in the room tonight at Fervo, that have taken shale technology and this idea, and now it's actually going to produce commercial power. That's crazy exciting to me. Let me throw out a few other things that I'm quite excited about. Fission power. Look, this is 75 years old, more than that, almost 80 years. Well, fission is 75 or 80 years old. Power, not that much younger than that. But we've got exciting new businesses. Curio, working on how to process waste. Deep isolation. How do we take that end of fuel cycle waste and keep it safe? SMRs, another technology I recently started to work in again before I got my new job. And I know we've got the eVinci team here. Like, this is super exciting. Fusion, my original dream, what powers the stars and why I went to MIT. Commonwealth Fusion, Rialta, and Zap Energy have all been partners in some form or another with ARPA-E. And fusion, that was super exciting 40 years ago, I think in the next few years, and certainly in the next decade, I think much sooner than that, we're going to see such significant advancements that the pathway to commercialization, to take this energy we know how to harness now and make it commercial, that's in the near future. That's just crazy, crazy exciting. We have intermittent energy sources, and solar is growing very fast. We're getting more efficient at taking panels, cheaper materials, and developing energy. The biggest problem there is the sun doesn't always shine, and we don't know when clouds are going to come and when it's not going to shine. But if we can get energy storage better, that's a game changer. So there's a lot of great work on energy storage. Ecogen, QuidNet, ion storage, and Sila nanotechnologies are all working on that together with ARPA-E, and I assume several of you are here today. That is awesome. Let me end by saying a few words about AI. I visited Los Alamos Labs, the first national laboratory I visited. As a kid, reading about physics and science and think accelerators and atom smashers, right? Who builds those, right? Those aren't at IBM, even those aren't at GE. Who builds atom smashers and accelerators and the things that allow us to understand nature at its basic fabric? Those are built at our national laboratories. The Department of Energy's laboratories, your partners, and probably many of you are directly cooperating with them, 17 just incredible labs that lead the world in physical sciences. So I wanted to go to Los Alamos first, to me, the mother of the national laboratory system. And this incredible gathering of scientists, engineers, chemists, and administrators to come together in a race. The Germans, Nazi Germany at the time, had a project also to develop atomic weapons. And we had one here in the United States. And finishing second was daunting. And we saw incredible efforts. I cannot believe the pace of innovation to develop an atomic bomb that helped bring World War II to an earlier end, saving tens of thousands, at least more likely hundreds of thousands of American lives, and setting us up to move into an age of peaceful nuclear power and a Cold War that, while frightening, saw lower deaths from war than in any period we know recorded, lower percent risk of death in war. So these weapons, while daunting, they've actually brought much more peace, not complete peace, but relative peace. Today, I think the AI arms race is that next thing. And I hate to call it an arms race, man. I'm a science guy, I'm a technical guy. But the applications of AI are not just in business efficiency, consumer services. AI for science will be unbelievable, I believe, in drug discovery and material science, and just doing things we didn't know that was possible before. But it also has huge applications in national defense, offense and defense. And it's critical that the United States is the leading nation in AI. And to do that, we have to be the leading nation in growing our energy supply. AI is just an energy-intensive manufacturing industry. It takes the highest form and the most expensive form of energy, electricity, and turns it into intelligence. You know, who wants only a little bit more intelligence, or maybe double a little bit? Now, everybody wants as much as they can have because it's going to allow us to do things we otherwise couldn't. And the only way we'll achieve that, the only way we'll get there, is if we can grow our energy system faster, faster, and faster. And that's why you're all here. Let me end there and just circle back to a thank you. Thank you for what you're doing. Thank you for your partnership with ARPA-E. Thank you for your partnerships with all the commercial venture capital firms, all different investors, with suppliers. Like, technology doesn't happen in isolation. It happens as passionate teams work together, deal with setbacks. Maybe your idea isn't right and you should follow a different idea. Maybe your idea is right and this is just an obstacle and you got to plow through it. We have to make a lot of hard decisions, and those are best made with partners and challenging ideas and back and forth. Science and advancement's not about uniformity. It's not about top-down control. It's about ambitious, passionate, innovative people engaging, challenging each other, bouncing ideas back and forth, and not giving up. And you're in this room because you succeeded in this endeavor so far, and people believe in you and have invested in you. God bless your tremendous work in helping energize our country and bettering the lives of people in this world. I'm thrilled. I got my new job because President Trump had an instinct for energy. He's not an energy entrepreneur or an energy innovator, but his instinct told him energy matters. Energy is the most important thing there is, and therefore the best thing for our country is to produce more energy and lead the world in energy. Production today and technologies for tomorrow. So to more energy and better energy. Thank you for all that you do. I look forward to learning more about all that you are doing. Take care.